Well, start off with, back in about a decade ago, we implemented guard cable along the I-70 and I-44 corridors. And that guard cable resulted in over 90% reduction in cross-median fatalities along those corridors. Then, just more recently, in St. Louis, we had the safety design build effort. And of that safety design build effort, we're anticipating 70 lives, serious injuries and fatalities reduced over the lifetime of that particular project. So a couple weeks ago, there was TEAM, and at TEAM, all the district engineers were up on stage and they were asked, hey, what's the next big thing with regards to reducing fatalities and serious injuries on Missouri's roadways? And they gave various answers, but I wanted to take a step back from that and say, well, what do all these big, amazing projects really have in common? And that's data-driven safety analysis, where we can leverage our data to make more informed decisions, make more targeted investments, and maximize the reduction in fatalities and serious injuries on Missouri's roadways. And that's what the crash prediction tool is all about. Essentially what it's doing is it's using methodologies from the Highway Safety Manual. And they're able to bring in roadway data such as lane widths, shoulder widths, if there's a curve or going over a grade, whatnot. Takes all that information in to come up with a predicted number of crashes. Now you can imagine in southern Missouri, where if you got whole roads that are going up and down, wind and left and right, anytime that there's a change in that roadway characteristic, you got to break it into a different segment because the predicted crashes for it's going to change. So doing all of that manually is a very tedious, time-consuming, and really impractical process. And so that's what the crash prediction tool is all about, is trying to leverage information and roadway data that we already have available in TMS to pull that data in, run all the safety manual methodologies, and then come out with a couple different exports. And those outputs include the predicted number of crashes, but also an expected number of crashes. So the predicted number of crashes is again based on the road's characteristics, but the expected number of crashes brings into account the observed crash history, or how is it actually performing in the real world. And so one of the expected number of crashes is really a blending of our observed crashes and our predicted crashes. So it's kind of a middle ground. And one of the benefits of looking at expected crashes is sometimes we might have a year or two at an intersection wherever crashes were just really bad that one year. And so everybody sees it as a significant safety need, but they might be overestimating the potential safety benefit of that. So using an expected number of crashes allows us to have a more realistic sense of what a safety countermeasure or safety improvement could have at a particular intersection. In addition to that, the difference between the predicted and expected number of crashes can lead us to something that we call potential for safety improvement. Essentially, we can identify locations where there's a big discrepancy between what's occurring in the field and what we would be predicting for that location. And we can identify, hey, there's a big discrepancy here, lots more crashes occurring, there's probably something happening at that location where we can probably make a relatively small investment to get the number of crashes more in line with our crash prediction. So, for example, we've pulled the top 10 expected crash locations in Franklin County. And two of the locations is an intersection along Route A and another one along US 50. One location along Route A is expected to have 7.7 crashes. The one along US 50 is expected to have 5.5 crashes. So we're at the one that's experiencing the 7.7 on Route A. You'd think we'd want to target for a safety improvement. But when you're looking at the prediction and in the context of the location, the 7.7 crashes that we're experiencing along Route A is much more in line with this prediction. So it's kind of operating a little bit closer to how we'd expect it to. But the setting of the one on US 50 is one where we would predict much fewer crashes associated with it. And there's a discrepancy there. And so because of that, we might be able to do a targeted investment there that can have a higher value improvement at that one location. Now, digging through all these tables can be kind of hard to understand and a little time consuming. So we've also developed a crash map here. And what this does is it's essentially plotting out a color coding scheme of level of service for safety. And that's a new term that we've developed to wherever it essentially is an assessment of your potential for safety improvement for any of these different locations. So if you're showing up in green, that's a level of service for safety 1. That means that the crash history that's out there is actually performing better than what we would predict. So, there haven't really been any crashes out there. Things are looking good. But we've got various different levels of service for safety going all the way up to 5. If you're at 5, that means that you're in the top 10 percentile of locations that are on the higher end of your potential for safety improvement. So that's wherever you're seeing the biggest discrepancies between your expected and predicted totals.